Hello and welcome to your video on Python animations. All right, so this is going to be our final sort of programming topic in the course. We're going to be learning how to make animations using Python. So what do I mean when I say the word animation? Basically, a logical sequence of changing images shown in quick succession that give the illusion of movement. All right. So what we're going to be doing is we're going to be creating lots of individual pictures. All right. We're going to use code to create those individual pictures. And the changes of those pictures, the changes in those pictures are going to follow a logical pattern so that when we show those pictures in quick succession, sort of like a flip book almost, it's going to look like the object is cleanly moving, not that we're looking at hundreds of discrete separate pictures. All right. Now, one of the terms we're going to use a lot in this unit is a frame, and a frame is just a single image in an animation sequence. So like this is a frame. This is a frame. Like every one of these individual pictures is a frame. All right. And I could draw arrows to literally every single one of those pictures because every single one of those represents a frame in the animation. Again, animation is just lots of pictures kind of streamed together in a logical sequence. All right. Now, how quickly do you have to show these pictures to kind of fool the brain, to make the brain think that it's seeing movement as opposed to discrete images? All right. Well, early silent movies, so if you go back in time and you kind of imagine those black and white movies that you've probably seen in like a history class or something like that, were 16 frames per second. And that's about the minimum that's needed to create or sort of trick the brain into thinking it's seeing motion. All right, so if we show you 16 discrete pictures per second, it might not look totally smooth, but it is going to look like the object is moving as opposed to just you're looking at separate pictures. Most video cameras capture things at 30 frames per second. And some recent movies run at 48 frames per second. So not that you can't go higher than that. You'll see some games that are running probably higher than that. But this is sort of the scale in which we're working with to sort of create this illusion of smooth movement as opposed to looking at discrete images. But in reality, it's just discrete images being flashed at really high speeds. And those high speeds are enough to trick the brain so that it thinks it's perceiving movement as opposed to separate little pictures. All right. So let's talk a little bit about movie files, because I think this is kind of interesting. MPEG, QuickTime, AVI are all called compressed movie formats. And compressed means they're using some technique to save space. This was one of the first topics we talked about with Huffman encoding tables, how to compress data so that it was smaller. And we saw that we could represent different letters with smaller combinations of numbers. And the more frequent letters got shorter strings and the longer letters got longer strings, but on the whole, we kind of saved space. Well, the way they do it in movies is they don't record every single frame. And if you think about it, if we recorded every single frame, that might mean we're recording up to 30 pictures for every second of film. All right. And if you've got a really long film, that's a lot of seconds multiplied by 30 pictures per second. All of a sudden, you're talking about a boatload of pictures, all of which, if it's high definition, are going to take a lot of memory to store. You could see how very quickly movies would get massive. So the way we get around that is this idea of compressing it. And what we do is we don't record every frame. We record some key frames, and then we just store information about the parts of the screen that change on intervening frames. So, for example, if you're watching somebody talk in front of a wall, all right, there's a lot of those pictures that aren't changing. Like the wall's not changing as the person sits there and talks. So instead of having to record that information over and over and over again, you record the wall once and then you just wait until there's a change in that wall. All right? And if there's no change, you just keep using the data that you have instead of having to restore data over and over and over and over again. All right. So MPEG is an international standard, AVI is a Microsoft standard, and QuickTime is an Apple standard. So you've probably seen those before, or at least kind of vaguely familiar, but that's the breakdown of how that works. And then mostly in this class, we're actually going to be creating animated GIFs. Now, these were originally designed to store a single image, but they have been extended to display sequence of images with a time delay between each. Doesn't support audio, so the animations that we make in this course are not going to have audio, but they are going to just be images set up in sequence to create sort of this illusion of movement or animation. So let's talk about how we're going to go about creating these animations. All right, so using our just picture commands, our programs will create and write a sequence of JPEG picture files. All right, so we're going to write code that creates a whole bunch of pictures in a folder. All right, and these pictures represent frames or individual pieces of our animation. All right, and the order of the frames is going to be determined by the file name. All right, so these numbers in the file name make sure that our animation happens in the correct order and we get this appearance of smooth movement. All right, but that's what we're going to be learning how to do, is how to create these sequence of pictures to sort of then create this illusion of a smooth animation. All right, so how are we going to save a frame in Jest when we're writing Python? All right, so there's going to be a function provided to you. All right, anytime we do animation code, this function will be provided to you, and it is called write frames. All right, so write frames requires 3 parameters. All right, the first one is the file number. So do you want this to be frame 0, 1, 2? So we also want to call this the frame number. All right, so this is the frame number. All right, but that's the number that's going to get stuck on the end of the file. So if you put in a 0, it's creating frame0.jpg. If you put in a 1 like we are down here, it's creating frame1.jpg. But this is the number that's going to get attached to the end of the file. All right, this is the folder that we're going to make those pictures in. All right, so again, we're going to be making lots of pictures. We don't want them just in that main window, navigator window that we're used to. We're going to create a separate folder that places all of those pictures in the folder so that they're kind of out of sight and not sort of taking over our screen. And then this is the Python picture object that we're actually creating the file with. So if you think kind of it's the old sort of write picture to that you've used all year long, only now we're calling it write frame. And it takes this extra feature of creating the file names for you. All right, so before we would do write picture to pick 1, comma, my pic.jpg. This is sort of doing all of that work for you with the additional, feature of attaching the number to the file name so that it handles all of that automatically. All right, and then this is just showing that if I change this to write frame 1, still use the frames folder, but this time write pic 2, this one is going to be a file that has pic 1 in it. This one's going to be a file that has pic 2 in it. And if those pictures are having like slight adjustments that follow like logical patterns of movement, our eye is going to perceive that as, smooth movement through the screen or whatever. All right. So these are some of the commands that we're going to be using, not the only ones, but this is kind of our first tool that we're going to need to start creating animations. Now, one thing is, this doesn't automatically create the folder for you. All right. It's going to assume that you've created the folder. All right. So in REPL, and I'll show that later, but there's the little plus sign and you can create new folders. So you must have the folder created. All right. And it doesn't have to be called frames, but it has to be some folder that you've created inside the project that we're then placing these files into. All right. So let's see how this all works. Let's see how we can make an actual animation. All right, so this is a very, very simple animation. All right, it's just going to make a red rectangle move across the screen. All right, so let's kind of break it down one by one by one. All right, so we have a loop here, for num in range from 0 to 30. So this is going to create 30 frames. Each time we go through this loop, we're going to create a picture, aka a frame, and they're going to be numbered 0 to 29. So this num variable effectively becomes our frame number. All right, this represents our frame number inside of our animation. Then every time through the loop, we're making a brand new empty picture. So every time this loop runs, we're making a brand new empty picture. And then we're drawing. All right, so when we make the empty picture, just a reminder, this is your width. This is your height. So I'm making a picture that's 300 by 200. And then I'm creating a rectangle inside of that picture. All right, so this is the picture that I'm creating it inside of, canvas, which I just created. All right, this is the X location. This is the Y location. This is the width and height of the rectangle. So this is the size of the rectangle. And its width and then height. And this last part, you're probably guessing, is just the color of the rectangle. All right, so I'm drawing this rectangle on a brand new empty picture each and every time. And notice that the XY locations are going to be changing because they're using that num variable that's attached to my loop. So the very first time, it's going to be 0 times 10, 0 times 5. The next time, this is going to go up to 1, so it's going to be 1 times 10, 1 times 5. Then this is going to go up to 2, 2 times 10, 2 times 5. All right, so it's going to keep drawing that rectangle in slightly different locations on this blank canvas that's being created each time. Now, just a note here, this XY coordinate, if you're wondering like, all right, is that the center of the rectangle, the right of the rectangle, where is it? X comma Y is the top left corner of the rectangle. So when we specify the X comma Y, if we have our rectangle, all right, that's being, well, this time it's actually a square because it's 50 by 50. Pretend that's a square that's 50 by 50. But this is the XY. It's the top left corner, and then it goes over 50 and down 50 from there. All right. This drawing is not to scale. I'm just going to throw that out there right now. Not to scale. All right. Then, after we do the add rect filled, then we actually write the frame. All right. Hold on. All right, this printed out weird. I totally missed that this happened. This is what happens when you sometimes go from Google Sheets to PowerPoint. But this should be just frames with quotes around it. Sorry about that. So this is just the word frames with quotes around it, which is the name of our folder, and then comma canvas. So this is going to be the frame number. Again, this is what we just talked about. This is the frame number. This is the folder. And this is the picture that we're writing. So this is actually going to create the file. This creates the file in our project. All right. And then the wrap up of this, kind of how we sort of tie it all together, is we create this movie object. All right. So movie equals make movie from initial file. And then we always start it by, again, this is our folder name. And this is the first picture that you created. All right. This is the start of the sequence. So that's always just going to be frame 0. Right? Once we've created this movie object, then we have to write it to an animated GIF. And again, I apologize here for not catching this earlier, but this should just be quotes rect movie dot GIF. All right. So just so you know, these two lines pretty much always stay the same. All right. Obviously, you can change the file name. You don't have to call everything, recmovie.gif. But for the most part, you're always going to do this movie equals make movie from initial file. Again, your folder name could be different if you change your folder name. The picture is probably always going to be the same. And then when you're writing it out, you can write it to sort of a different file if you so choose. All right, so let's take a look at what this actually is going to look like and what this is going to do. All right, so what I have here is, let me turn the light off there and get rid of the glare a little bit. Not working as well as I wanted to, but we're going to stick with it. All right, so what we have here is the code that we just talked about. There's our make rectangle movie. All right, we're making empty picture. We're adding the canvas. There's our num times 10, num times 5. So when we run this, what it's going to do is it's going to create a folder full of pictures. All right, and those pictures are slightly different from the ones before it. We keep drawing the rectangle in a slightly different spot, but it's created 30 different images of that rectangle in a slightly different spot. And then what we end up with is when we actually click on the animated GIF or GIF, it's showing it as continuous movement, but really it's just that rectangle being slightly moved and then those pictures being shown in quick succession. So to our eye, it looks like continuous movement. Now, the recording from the computer to this to that might make it look a little more choppy. It does look much more continuous on like an actual screen if you're looking at that all by itself. All right, but that's kind of the general idea of what we're doing here. All right, so how does this actually work? All right, we're going to kind of trace through the program here and see what's actually happening. All right, so we have our loop. It starts at 0. So the very first time, num is 0, which means the location that we draw our rectangle at is also going to be 0, 0. All right. Then number goes up to 1. So the location that we draw our rectangle at is going to be 10, 5. All right. And again, remember the top left corner of your screen is 0, 0. So there's 0, 0. And then we start moving it, and the x is moving further than the y. So this is now 10, 5. So it's moved over and down from its starting position. And then it just keeps going there. All right. So num goes up to 2, and it becomes 20, 10. Num goes up to 3, it becomes 30, 15. And then I'm just going to do some dots. Num goes up to 28, it becomes 280, 280, 140. Num goes up to 29, and it goes up to 290 and 145. But we just keep creating pictures, and we keep drawing that same rectangle over and over and over. We just draw it in slightly different places. And that's what makes the rectangle start up here and then move down to that bottom right corner. All right, so we're having this picture move little bit by little bit by little bit, but you could see how you could use this to make a more complicated animation. All right, obviously there'd be a lot more code. It's not just a single rectangle, but you start moving pixels and you start moving pictures slightly, like little by little by little, and all of a sudden it looks like an arm is moving, or it looks like somebody's jumping up in the air. And yeah, there's a lot more that goes into it, but this is sort of that underlying premise of you're creating picture after picture after picture in a logical sequence to create this appearance of movement. All right, so wrapping up kind of those last two lines that were at the bottom there. So it says to create a movie from a sequence of images and folder frames. These were these last two lines that were there. Again, I apologize for this stupid mistake. It should be recmovie.gif and then quotes and then close our parentheses. So to view the movie, you click on the animated GIF file, recmovie.gif. I already kind of showed you that. Again, for this to work, you have to have the folder called frames in your project. Let me show you that again, because I said I was going to show you that and I didn't right away. But when you're creating a folder in REPL, it's right up here. So you've got this folder with the plus sign on it. You click add folder. And again, you can call it frames or you can call it something else. You're going to see that as we do these other demos here, I have frames 1, frames 2, frames 3, and they each have a different series of pictures in it. But for my code to work, I had to manually create that folder ahead of time. The code doesn't create the folder for you automatically. So just be aware of that when you're doing these, it's important that you have the folder created. And then once it's created, your code will handle creating all of those individual images they're getting placed inside of there. And then this line is taking those individual images and turning it into a single GIF file that you can play and watch over and over again with your animation. And it just plays it on sort of an automatic loop. All right. So let's take a look at a couple more examples here. All right. So what animation is created by the function below? Trace its execution by filling in the table on the next slide, showing the values of num and the XY location of the rectangle used in creating the first 4 and then the last 2 frames of the movie, then sketch what the first 2 and last frame of the movie would look like. All right, so we've got another rectangle movie here. All right, we're sticking with rectangles today. We've still got our frames here. All right, we're still making our empty picture. So this is our blank canvas. Again, this is the size of our frame. and it's width, comma, height. And then the only thing that's really changing is where we're placing our rectangle. So in the first one, we did num times 10, num times 5, and that was it. This time we're doing 300, which again is the width of our rectangle, minus num times 10, and then num times 5. Otherwise, everything else is pretty much the same, including this dumb typo that I didn't get rid of. And it's embarrassing, I'm not gonna lie. All right, so again, that's our frames folder in Canvas. And then this down here is pretty much exactly the same, including this right here that I apologize for. All right, so let's kind of think about what this is going to do by filling in the chart, and then we'll try to visualize it before I actually show you the end result. Okay, so when num is 0, all right, if we plug num 0 in here, it's going to be 300 minus 0 times 10, which means it's just going to be 300. And this one is going to be num times 5, which is going to be 0. So it's going to draw the rectangle at 300, comma 0. Now remember, this is the top left corner. All right, top left corner. So when we start, we're going to be drawing the rectangle, but it's actually going to be outside of our field of vision because we're drawing it at this right edge of the picture. All right, then num is going to go to 1. So 300 minus 1 times 10 is going to give us 290. And then 5 times num is just going to give us 5. So now we're drawing the rectangle a little bit down and a little bit over. So we're going to start to see part of the rectangle because now that part is being drawn on the screen. All right, and then it just keeps going from there. So 2 is going to be 300 minus 2 times 10, or 280. And then just 2 times 5, which is 10. And then you can kind of see the pattern at this point. This one keeps going down by 10. This one keeps going up by 5. All right, by the time we get to the very end, this is going to be 20. 280, 28 times 10 is 280, minus 300 minus 280 is 20. And this is going to be 140. And then the last one's going to be 10 and 145. All right. So the rectangle starts here, and then it's going to keep moving across the screen in this direction. All right. So basically, the rectangle moves from the top left, or sorry, the top right, to the bottom left. Corner. Now, again, let me show you that I'm not lying to you. All right, so let me bring up the code. So let's see. All right, so there's make rectangle movie 1. There's the 300 minus num times 10. This time I'm writing it all to the frames 1 folder. So if I click here in frames 1, there's my first picture, and the rectangle's off the screen. Then we can start to see it slowly starts showing up. All right, and we keep getting a little more and a little more and a little more. And then if we look at the final file that gets created, instead of looking at each individual picture, there's our final file that shows it moving from that top right corner to the bottom left corner. But again, just by drawing the same rectangle again and again and again on a blank canvas, but subtly changing its location. All right. All right, so let's take a look at another one here. This one says, fill in the missing inputs to the add rect fill function below so that it creates an animation of a red rectangle that starts at the top in the middle and move down. Trace its execution by filling in the table on the next page. All right. So if we want it to move down and just down, it means the X stays the same and the Y gets bigger. All right, because again, the top left corner is 0, 0. So to make it move down, we actually have to increase the Y value. Now, it says it wants to show up in the middle, and we know that this 300 is the width. So you might be saying to yourself, whoops, okay, 300 divided by 2 is 150, but that will just give you the middle of the canvas. All right, there's your 150. We have to account for the size of the rectangle or square, which is 50 by 50. So if it's 50 by 50, that means we've got 25 on one side of the line, 25 on another side of the line. So that's 25, 25. So considering we draw the rectangle from the top left corner, if we want it to be in the center of the screen, the X value is actually going to be 150 minus the 25, or 125. And then if we're going to move it down, we've already seen how to move it down, all right? We've done that on the last two exercises, all right? We can have it move down by doing something like this, all right? And that just means that for each frame, we're moving it down 5 pixels, all right? If we change this to a smaller number, it would just move it slower, all right? Because it wouldn't be moving as much on each frame. But we'll just leave that there because that's what we've been doing. And then it wouldn't be this video without fixing this stupid mistake that just is haunting my dreams. All right, and then we'll fix it down here as well. All right, so again, this is us finding the center, and this is us allowing to move it down. And then if we're going to trace the execution, let's use our code and see what that actually gives us. So 125 has now been hard-coded into our program. So no matter what frame it is, the X is not changing. The X is staying 125 the whole way down because it's no longer tied to that num variable. It is just 125, 125, 125 all the way down the sheet. Now, the Y is the one that's tied to the num variable. That's the one where we just filled in num times 5. So at the beginning, it's 0 times 5, then 1 times 5, 2 times 5, 3 times 5, all the way up to 28 times 5, and 29 times 5. All right. So the very first rectangle is going to be drawn right here in the middle. Again, it draws from the top left corner. So there's our 125, comma 0. And then we just keep drawing them a little bit lower and a little bit lower. And it's going to make the rectangle look like it's just dropping through the screen because we just keep lowering it little by little by little by little by little by little by little. All right. And let's get this back up so you can see it. All right. So again, all right. Here's our actual code. All right, so the X is set to 125. The Y is set to num times 5. This time I'm writing it to the folder frames2. So again, I've already made a folder frames2 over here. If I go into frames2, I've created those individual pictures, and you'll notice the X isn't changing. I'm just redrawing that rectangle a little bit lower on the screen each time. All right, so now if I look at my demo2.gif, there it is, my dropping rectangle that just moves down through the screen by changing the Y value, but leaving that X value locked in place. Okay? So let's look at one more example here. All right, so we just did exercise 2. That brings us to exercise 3. And it says, what animation is created by the function below? Again, trace its execution by filling in the table on the next slide. And then we'll look at it again in Jest and see what it is actually giving us. All right, so if we look at this, all right, we still have our for num range in 0 to 30, so same size animation. All right, we're still creating the same canvas with our same width and height. So there's our width, there's our height. And then what's different here is this time our X is 125, that's locked in place, but our Y is 200 minus num times 5. All right, so we've sort of flipped that Y around. And then again, we're going to write it to our folder frames. And the individual picture that we're writing is called canvas. And then once all of those pictures have been created, all right, the for loop creates all the pictures. Then we take all of those pictures and actually create our .gif file by making a movie object. So make movie from initial file. This goes into our folder, gets the pictures, creates the movie object, and then we write that object to an actual file that can be opened and shared and sent to anybody with your own little animation there. All right, so we'll trace this, we'll think about what it's doing, and then we'll see if our tracing and intuition was correct. All right, so when num is 0, X is going to be 125 because it is no way connected to num. It's just a straight 125. And our height is going to be 200 minus num times 5. So 0 times 5 is going to be 200 minus 0, or just 200. So the very first picture that we're drawing is going to be at X 125, but Y 200. And again, since it's the top left corner, it's actually going to be off the screen. We're not going to see that very first picture because it's drawing it from the top left corner. We started at the very bottom of our canvas, so it's going to be off the canvas and we're not going to see it. All right, then let's go, and num's going to become 1. X will still stay 125. That's not going to change. But now we're doing 200 minus num times 5, or 200 minus 5. So that's going to go to 195. And then I think at this point we kind of know what's happening here. This is going to be 125. This is going to go to 190. This is going to stay 125. This is going to go to 185. All right. This is going to stay at 125. And at this point, we're subtracting 140. So that brings us all the way up to 60. And again, at this point, 125, and this is going to go to 55. So even though the y's are getting smaller, remember, since this is 0, 0, it's going to actually make the box look like it's moving up. And this time we have a box that's going up through the screen as opposed to down through the screen. All right, and let's take a look and see if our intuition is actually correct on this. So here's our code. All right, there's, where is it? Nope, not that one. Make rectangle 1, make rectangle 2. Where's make rectangle 3? Oh, there it is. All right, so there's our empty canvas. Again, there's the x being set to 125. There's the 200 minus num times 5. This time I'm writing it to the folder frames 3. So if I look at that first picture, all right, it's not there because it drew it off the screen. And then slowly but surely, the rectangles get just a little bit higher, a little bit higher, a little bit higher. And if I look at the final product, you can see that they're rising up through the screen. All right, so I just created this animation of the block rising. All right, so this is just very simple, showing you how to move something to the left, how to move something right, how to move something up, how to move something down, how to move something diagonally. All right, but little demos that are just showing you that by creating these pictures in sequence, you can create this illusion of movement. All right, and that's what we're going to be doing in the next lab. All right, you're going to be doing some more involved animations where we're not just moving drawn rectangles, but we're moving pictures. And then eventually you're going to be creating your own little mini animation. And again, you know, think more like screensaver almost. You know, we're not going to be creating big elaborate movies here, but we are going to be writing code that creates little mini animations that have things moving around the screen, have pictures showing up, disappearing, et cetera, and playing with some of those things. All right, so I hope this was helpful. Again, we'll be starting a lab after this, and if you have any extra questions, just let me know. All right, have a great day. Bye. Computer's being a little glitchy here, so it doesn't want to stop. But it'll stop eventually. In the meantime, you can just listen to me mumble as I'm waiting for the computer to actually stop recording. At some point, I might just cut out because it's going to have stopped. We'll see. One can hope. Either that or you're just going to listen to me for the next hour talking to myself as I try to get this computer to stop. Please stop.